Good afternoon, ladies and gentlemen. Welcome to our second webinar in the six-part series hosted by Rockflow Dynamics. My name is Larissa Zimmer from RFD Kuala Lumpur, and today's session will be hosted by my colleague, Mr. Ari Krishna, who is a senior geologist also based in Kuala Lumpur's office. We would like to thank everyone who registered and allocated their time today to attend these webinars. The response from each and one of you has been overwhelming, and we hope you enjoy these sessions. Our RFD team is working around the clock and will continuously strive to provide the best support we can in these trying and fragile times. Please do not hesitate to reach out to our support team for assistance. I'd like to provide a brief run-through on how to navigate yourself during this webinar session. Once you've logged on, you'll be automatically muted, and should you have any questions in mind, kindly use the window in the control panel on the side of your screen and ask away at the very end of the session. If we are unable to answer all questions live, we will answer them afterwards and share it with you via email. This webinar session will be recorded and uploaded onto our RFD Europe YouTube channel. Last but not least, if you have any further questions and inquiries, please feel free to reach us at asktnav@rfdyn.com. This webinar series will be hosted from 6 of our worldwide support offices from over the next 1 month, starting from Aberdeen, Kuala Lumpur, Houston, Calgary, Moscow, and Perth. Today, we're tuning in from Kuala Lumpur, Malaysia. Today's topic will be focused on geology and big data, and next week's topic will be focused on dynamic build-up well test simulation in Model Designer by Eddie from our Houston office. Today, we're live from Kuala Lumpur. In today's webinar series, we will demonstrate you each stage of the integrated workflow that's available in tNavigator. If you're interested to learn more on our modules, do not hesitate to get in touch with our teams, and we'd be more than happy to help. Before we begin today's session, I would also like to highlight that the new object modeling for facies modeling is now available for tNavigator 20.1, which is our very new release update. I would like to introduce our presenter for today. Mr. Ari Krishna is a senior geologist with over 15 years of experience and is based in our Kuala Lumpur office and has an extensive work background as a geologist. He has worked for numerous companies such as Petronas, Schlumberger, and many more. He possesses a Master in Petroleum Geoscience from the University of Malaya and a Bachelor in Geology from Bandung Institute of Technology. Without further ado, let's begin today's session. Thank you, Ari.
Thank you, Larissa, and very welcome to ladies and gentlemen here for our second webinar, tNavigator live webinar series hosted from Kuala Lumpur. I'm going to cover the topic for today for geology and big data. So my name is Ari Krishna. I'm the senior geologist based in Kuala Lumpur here for Rockflow Dynamics. For today's topic, I will cover and focus on the well correlations and utilizing automation and neural network. Some outlines for the presentations today. It will be covered in two main parts. The first one will be several presentation slides, and the second one will be a live software demo. And at the end of the session, there will be question and answer session if you guys have further questions. Big data in oil and gas industry. Big data is an emerging trend, and it's possible because of the recent technological improvement, not only in oil and gas industry, but also in other industries such as healthcare providers, e-commerce like Alibaba and Amazon, and all of these industries has been utilizing the big data in their day-to-day basis. But us here in the oil and gas, some of us hasn't been aware what is big data actually is. A survey conducted in 2012 in some of the major US oil and gas companies, 70% of the participant was not familiar with big data and what's the application. However, within only in the next 6 to 8 years, in 2018, there was a survey conducted, and 81% of the oil and gas executives already considering big data to be among of the top 3 priorities in their companies. And this was listed as their priorities because of it has been known as it improves efficiency in their day-to-day job. So by definition, this is from IBM, one of the major computer company in the world. By definition, big data or big data analytics are actually new technologies that can employ big amount of data sets. And it have these 6 main characteristics. First one is the volume. Of course, it have to involve a large amount of data set and information. Second is the velocity. Velocity here means is the speed of data generated. The last 20 years, we have been drilling more wells, we have been shooting more seismic compared to previous time. Variety is the various type of data. You have well data, you have seismic data, production data, lab data. All of these different types of data needs different kind of treatment and analysis. Veracity here means the quality and the usefulness of the data for analysts and making decisions. So it's basically the ability to recognize clean data versus raw data. The value here means how much value you get out of the data compared with your investment. For instance, 3D seismic data, even though it's more expensive, it gives you more value because it gives you a better understanding of your reservoir. And the last thing, of course, is the complexity. More data that you have, it will be more complex. The more modern data that you have, it will be more complex. So all of these categories define big data definition. But why does it matter? Especially in the oil and gas. Does it really matter, or why it matters now? Right. So oil and gas industry has been there for more than 100 years. In fact, the first exploration well in Southeast Asia was in 1885. So it's more than 120 years ago. It was done in Sumatra by the Dutch, right? So imagine 100 years of data accumulated there and need to be analyzed. Back then, people don't really need because there are not many data and you don't have the tool to do that. So to do some analysis or interpretation, what people are doing is the traditional approach. They combine their domain knowledge expertise, geologists, geophysicists, engineers, analyzing the data on a manual approach, for instance, doing seismic interpretation on hard copies, and they do their interpretation and make the decision based on that. However, as time goes by, in the 90s or maybe late 80s, some technology already comes. There are computer, workstation, and there are interpretation software, modeling and simulation software. Some of the software includes some automatic interpretation. So in the 90s or early 2000, the standard approach is already being implemented by all of the oil and gas companies in the world. So this become the standard industry approach. However, data is getting bigger and bigger. We shoot more seismic, we drill more wells, right? And some government and national oil companies in the world has even opened the data to be public, right? So the data is abundance. And thankfully, the technology improvement is also becoming advanced. So not only data that becomes bigger, but technology also become better. So now you have the option to do cluster computing, cloud computing, GPU based on gaming experience, right? Some of the software now have very sophisticated artificial intelligence, machine learning process, and everything. So the technology becomes better, the data becomes bigger. However, if you notice here, the circle of the domain knowledge cannot be as big as the data and the technology itself. What it means here is that because human brain have limitation, right? And because of this limitation, it will affect the productivity and the efficiency. Example, a geologist maybe can only interpret 20 wells, do well correlation for 20 wells in one day. If he's asked to do interpretation on 200 wells, maybe he need a week or 2 weeks to do that. So again, human brain have some limitation. So what we need to do, the data is abundance, the technology is there. What we need to do is we have to have the paradigm shift. We have to shift our approach. We have to embrace the technology and the data from domain-centric, domain knowledge-centric, becoming more data-centric approach. And this what has been done by all the major companies in the other industries, such as Facebook, Amazon, or even Uber or Grab. They use this data-centric approach to make the best analysis and make the best decision. For us in the oil and gas industry, what we need to do is we embrace the technology and we embrace the abundance of the data and shift our approach so we can maximize and optimize the technology into its full capacity. I give you a very easy example. Neural network has been there for I think the last 15 years, last 20 years. But I think only now people recently aware the added value of what neural network approach can give them, right? So the value, of course, whenever you make this shift, this yellow circle here becomes bigger because you are embracing more the technology and the data. So it will give you value in terms of efficiency, you will have time reduction, and eventually it will help you in better decision making. And the technology is not in the future, it's already there now. Most of the major oil companies or oil service companies have already this technology, right? For instance, cluster computing, cloud computing, CPUs with multiple GPUs. So it's not only for video gaming, but also for us in the oil and gas industry. And you can also even utilize laptop with external GPU. So these are sort of examples that give you the idea that the technology is already there, the data is abundance, it's just the matter of whether we are ready to embrace this. All right, so the next few slides will show you why tNavigator is the option, is the right choice to do big data analysis. And for this particular webinar, I will focus on the geology part. tNavigator is a new piece of software. It's a new piece of technology. It was built on C++ and CUDA, so it have a parallel computing. It's very light, yet it's very powerful. So we have the ability to do cluster parallelization, cloud computing. It's fully GPU enabled. You have also the options to do machine learning and artificial intelligence. And on top of that, you can handle big data, big numbers of wells, big models, multiple millions of cells. You can handle that in tNavigator on a standalone laptop. I'm pretty sure most of you are familiar with this loading icon. An example, if you open a project that contains large of volume of seismic or maybe big number of well data, then this is a typical thing that you have to face. Whenever you load the project, it will take maybe 2 minutes, 5 minutes, or maybe 10 minutes to load the project. You haven't even worked. And it's not really a good thing to start in the day whenever you want to start your interpretation. So the scenario here, let's say you want to work on multiple fields. These multiple fields, of course, have maybe hundreds of thousands of wells, right? And then you want to do a very quick assessment. The map here showing you an example from Sabah and Sarawak, from Malaysia, right? From Malaysia, and let's imagine you have to work on a basin scale, in this case 2 basin, but you want to do a very quick assessment. Typically, the challenge that we are all facing as users here, geologists and geophysicists, is how many wells that you can have in a single project, how many wells that you can load. And on top of that, how many of those wells can you visualize and do interpretation in a single time? The image on the right there showing you a very good example of a large giant oil field. It's from Ghawar field. It's from Saudi Arabia. This one field is have about more than 3,000 wells, and you can compare the number of wells that was drilled before 2000 and the last 20 years. The last 20 years actually have much more wells. So it's a very good example of a practical oil field that can get benefits of implementing big data approach. So can TNAV handle thousands of wells in a single project? Let me show you in the next few slides and the demo. So in the demo, I will show you using a teapot dome demo project. This project contains about 1,316 wells and have about 60 markers and 20 type of logs. So this demo will show you, the first demo will show you how long it will take to just open the project. Right. So as you can see, tNavigator is a very light software. It's just an executable file. You don't need to install it under Windows registry. You just have to copy paste onto your desktop or wherever. And you can have the option now to have a dark theme, just like WhatsApp and Instagram. And then let me put a timer here and then show you how long will it take to open a project on a standalone laptop like this, and open a project that contains 1,360 miles. Right? It might take sometimes, but I guarantee you it won't take minutes. It even take less than 20 seconds with all the well displayed in 3D and well section together. And you can still visualize and maneuver the 3D window as you wish. All right, and the next video will show you how to do well correlation and neural network utilizing all the information available in your project. So this is a 3D display displaying all the wells, and then you can use this information cursor. You just hover around your 3D there, right? And then the information will show you exactly what's the information, the well name, the depth, the marker name, and the horizon name. And you can also do other things. For instance, you want to do a quick QC on your depth structure map here. You can manipulate the legend. You show the legend, right? And then you can manipulate, you can filter out the lower or the deeper depth interval here, right? For instance, like this. So I can see which is my potential oil accumulation just based on the depth structure. It's very light. And then you can see tree structure here. And if I focus on the bigger area, I can the higher area, I can show it like that, right? So it's very simple and convenient. So the next video will show you how to do well correlation. Us as geologists, typically we like to create multiple well section, right? Parallel to the structure and cutting the structure. So here I'm just going to show you an example for arbitrary kind of well section. So I can just make a random line, right? You can adjust the circle size to cover how big the size of the area is, and then you can draw it freely on your 2D window. And you can see the line there are the well section connected, right? And this well section creation, is not only act as a well section, but also as a well filter. So you can activate the well filter for both windows. So you can see something like this. And now I will show you the well section itself. As I told you before, this well section contains, this project contains 1,316 wells, and I have the ability to display all of my wells in a single well section without any significant lagging problems. So you don't have to worry that the project will crash. So you can display everything here. In this example, I'm just showing the gamma ray, but now let me show you the well section that we just created earlier. So you can simply go to the well section filter, and these are the well section that we have just created. Of course, the template of the logs, you can set it inside tNavigator, and then you can have your preference well section template, right? So for instance, here I have a triple combo that I already set, and this can be shared to other projects as well. So you just need to build one template. And the well section here is very interactive. If you want to display it, you can display it in a full screen mode, right? So it will be very beneficial if you have a dual screen and you want to display all the wells in one screen or two screen. And then you can basically display all this. I think this is about 400 wells in a single well section, right? And other things that you can do, of course, all the basic functionality for a well section. You can flatten the marker on certain markers, or you can zoom in, zoom out the scale by doing it interactively on the screen, or you can just type the number. That is doable. Okay, the next example that I would like to show you is a very interesting feature, what we call automatic correlation. So imagine that you have to do a very quick analysis or correlation utilizing all the 400, 500 wells, but you don't have enough time to do it. So what we can do is you can start with your own initial interpretation, manual interpretation. Let's say I start with 3 or 4 wells here. I put it on my top of my SAN, and I use my gamma ray as my correlation point, right? So it will recognize the marker that I have put and will recognize also the gamma ray value that I input. And you can use multiple well logs here, but in this example, I'm just going to use my gamma ray. So within seconds, you can see here that I have a new marker in color in green. Let me make it bigger in size so you can see. So you can see in terms of seconds, I basically have created a new well correlation throughout my hundreds of wells. And then you can QC it, you can flatten it on certain markers so you can see the thickness variation, right? It is very helpful and beneficial if you want to work with this type of large data set. And if you display it in your 3D like this, you have that marker distribution along the 400 wells. And then if you compare with the initial 4 interpretation that you do, you basically do this within few seconds. And of course, after this, you can continue to the next work, which is typically you want to create a depth structure based on your markers. So you can do this very easily, of course. You just need to input the well logs, the markers, and you can choose what kind of algorithm that you want to do. So there is convergent gridding, inverse distance weighting, and then in a matter of seconds, you have the result. And of course, you can display it with contours, different kind of display. All right, and this particular demo is also another interesting feature that is now available in tNavigator. So this is the neural network function. So let's say I have one core wells only. This first well that I use, so I just interactively draw there my core interpretation. I have about 4 lithophases, my shale and sand and silt. Let's say I have that, and I want to use this information as a training to train tNavigator and to make a correlation with, let's say, my gamma ray, right? I use my gamma ray. This particular gamma ray I already normalized, so it have a consistent value throughout the field. And of course, you can use multiple input data. In this example, I'm just going to use gamma ray, so it gives you a easier understanding. So now the software will look to the entire field to see which wells have that gamma ray input, and then after it have that all information, it will train, and based on our initial interpretation, it can train the software to recognize where is the potential max sand in all the other wells. So you can see here, that's my new interpretation based on my neural network. I just need to change the type of log from continuous to discrete. And I can even make the template the same as my initial phases interpretation. So if I make it the same as my manual interpretation template, so you can see now I have a consistent sand, silt, and shale interpretation throughout my 400 to 500 wells. It's very easy, just a matter of seconds, you can get this for all the wells. Okay, so the summary for that demo and the big data explanation just now is that there are lots of technology out there that already have the ability to do parallel processing and its high performance. And one of it is tNavigator. It has the ability to handle big data, even though the software itself is very light. As I mentioned before, it's just a simple executable file that you need to copy paste on your desktop. It has the advanced well correlation and mapping functionality for geologists. The static modeling is not covered here, but it was covered in the previous webinar, so it's all connected in one single platform. And now we have the neural network and machine learning option available, not only for well logs, but also for seismic attributes. tNavigator is an integrated workflow covering from subsurface all the way to surface, from seismic to seismic geology, modeling, and engineering. So it's an integrated on a single platform. Again, tNavigator enables geologists, reservoir engineers, surface production engineers, and combine it to do some uncertainty analysis in a single platform. And these are all enabled in tNavigator, one product from Rockflow Dynamics. This slide ends my presentation. So now we open session for question and answer.
Thank you, Ari, for the insightful presentation. As spoken earlier, if you have any questions you'd like to ask, feel free to include them in the control panel and we'll answer them for you. Let's have a look at the questions right now. Okay, I have our very first question here. Can tNav load seismic data and perform seismic interpretation? How about seismic attributes?
All right, thank you, Lisa. So yes, tNavigator, as I mentioned, is not only a static modeling application, it's also a geophysics visualization and interpretation software. So now using tNavigator, you can load your seismic data, you can do seismic interpretation, horizons, and faults, and in fact, the newest version already have the ability to calculate seismic attributes. So yes, now it's all available within a single platform in tNavigator.
All right, second questions. After automated the faces training image, is it possible to show the correlation number how well after automation?
Okay, so we have a log information under the settings there, so you can check it there. But we are still working on that to improve because neural network is still new. So we are working on that to give you a better kind of feedback. Now it's available, but in a very basic kind of functionality, but we are working on that, improving on that continuously. Yeah.
Okay. Um, last but not least, what is the constraint in automatic well correlation?
Okay, the constraint probably will be the way you set the parameter, right? If you set the parameter too narrow, then it will have difficulties to recognize the next pattern. So in terms of parameter, you will have to do a trial and run to see what's the best parameter that you want to input. But in terms of number, we don't have limitation yet. We have been testing this with 7,000 of wells in a single project, and it works, right? And the other thing that I think would like to add on that is you need to include, so for instance, if you want to include multiple well logs, you need to have a certain relationship between that different logs, and that it will only work. Otherwise, if you have a contradicting information, it will confuse the software, and then it wouldn't have the better answer for you.
Okay. So today, that's it for today. As spoken earlier, we have an overwhelming amount of questions, but fret not. We will answer them afterwards and share it with you via email. Our session today will be uploaded on RFD Europe YouTube channel. Make sure to catch our next webinar session on the 7th of April at 2:30 p.m. GMT, hosted by Houston's office. Thank you everyone for joining today's session. Thank you, Ari. There will be a short survey for you to provide your comments at the end of this session. Till then, we hope you enjoyed the session and we look forward to seeing you in the nearest future. Take care and stay safe.